Hello and welcome to the Terminology Leading Practices stream of SNOMED CT Expo 2020. My name is Kathy Richardson and I'm a Senior Terminologist at SNOMED International. I will be moderating today's session. Please use the Q&A box located on the left of your screen to type your questions to the presenter. Questions will be answered at the conclusion of the presentation. I'm now pleased to introduce John Grimes from CSIRO, who will be presenting Pathling, Bringing the Power of SNOMED CT to Analytics App Development and Workflow. John, over to you.
Thanks, Kathy. My name's John Grimes. I work in the Health Informatics practice at CSIRO. I'm going to talk a bit today about the work that we're doing in the area of tooling for health data analytics. We've come a long way and we have been very successful in promoting the adoption of SNOMED CT within data capture. We're starting to see real-time coded data come in through the implementation of modern electronic health records in the hospital setting. However, the level of usage of this data within the analytics context is still very low. Why is that? We think that this is because the level of capability required to understand and apply SNOMED correctly is still quite scarce, and tools are very general and don't do much to help with tasks specific to analysing terminology-coded healthcare data. Could we create analytics tools that assume standard representations of healthcare data and make that data easier to work with? Could we target the sophisticated use of SNOMED CT and build user interfaces that make this accessible to the average analytics user working within a healthcare service? Could it be possible to lower the level of complexity of these tasks while also incentivizing the ongoing standardization of data capture and transformation? We could use FHIR as the information model and use its first-class support for clinical terminology to harmonize the query of the information model alongside the terminology. Using FHIR would also have the added benefit of leveraging the wave of implementations currently moving towards this standard, lowering the cost of adoption and increasing reusability across a growing ecosystem. Pathling is a FHIR server with special powers. It implements operations that are aimed at assisting with analytic workflows and powering analytics apps. It can also integrate with a FHIR terminology server to expose powerful query functionality for SNOMED CT and other terminologies. It's designed to complement, not replace, a regular transactional FHIR server. We've tried to design Pathling to be super simple to deploy, and it is possible to use it with zero configuration. Pathling is distributed as a self-contained Docker image, so there are no dependencies and you can run it using a single command. We have a Postman collection which contains lots of example requests, and there is a demo instance that you can use to run them against. This is an overview of the main operations currently implemented within Pathling. I'm going to take you through each of these in a bit more detail. First, we'll talk about the import operation. Import is how we get data into Pathling, keeping in mind that the analytic use case is quite different than the use cases targeted by a transactional FHIR server. We're often dealing with large volumes of data and we need it to be efficiently transferred and imported within a single operation. FHIR operations are invoked using a set of parameters, and the parameters for the import operation are very simple. You give it a location at which it can retrieve an NDJSON file containing all the resources of a particular type. Any number of resource types can be imported simultaneously. NDJSON is just a very simple way of concatenating a whole bunch of FHIR resources into a single file. This makes it easier to deal with in bulk and is more efficient than a FHIR bundle for large volumes of data. So this is an example import request. Pathling can currently retrieve the data from Amazon S3, Hadoop file system, or just a regular file system. Pathling doesn't actually keep track of any state. You just point it to the locations that you want it to import the data from and write the transform data to. On the left, we have a bunch of NDJSON files containing FHIR data we want to import. On the right, we have the Parquet files that Pathling transforms the raw FHIR data into, which power the query functionality. Parquet is a standard format used by many different analytic query engines and is designed for aggregate query in parallel over-structured data. Because this format is supported by many other tools, you can pick up the Parquet files that Pathling produces and use them elsewhere. So now that we have some data in Pathling, what are we going to do with it? Let's talk about the aggregate operation. The aggregate operation is a bit like a pivot table as an API. You give it aggregations, groupings, and filters, and it gives you back grouped data in a table. This is useful for exploratory data analysis and also for powering dashboards and visualizations. We express these aggregations, groupings, and filters using a language called FHIRPath. This provides us with a succinct way of navigating the FHIR data structures that is aware of data types, resource references, and clinical terminology. This is a simple example of a FHIRPath where we retrieve all the reason codes for a prescription. FHIRPath transparently handles the fact that this element has a cardinality greater than 1. This is a more complex example where we retrieve all the qualification codes for the clinicians involved in an encounter. Here we need to move across references between different resource types. This sort of thing generates a lot of repetitive and error-prone code when using a general-purpose query language such as SQL. Here is a worked example of a request to the aggregate operation. In this example, which is the example previously demonstrated by SNOMED International, we are taking a look at the treatment of patients with rheumatoid arthritis. One of the treatments for this condition is a drug which suppresses the immune system, which can increase the risk of contracting lung infections for some patients. Here we are counting the number of patients. This is our aggregation expression. Then we group the patients by whether they have been prescribed a TNF inhibitor. Here we use SNOMED CT expression constraint language to describe medication concepts that are subsumed by a grouping concept. Then we also group the patients based on whether they have contracted a lung infection. Again, we use ECL to describe a set of concepts based on their attributes. In this case, finding site and pathological process. Finally, we apply 2 filters. One to only select patients with autoimmune arthritis, and another to only select patients with a type of chronic lung disease. Pathling will call out to a FHIR terminology server to resolve each of these ECL expressions into a set of codes, which are then matched against the codes within the FHIR resources. This is what the aggregate request looks like. We provide the aggregation, grouping, and filter expressions in the request, and we get back a set of grouped results which have labels that correlate to the groupings that were requested. This is a bit of a preview of how that would look in JSON. And this is what we might get back from our example request. Here we have each of the unique grouping values that were encountered in the data. Only the data that is matching our filter conditions is included, and the result of the aggregation function is shown in the rightmost column. As a demonstration of this functionality, we built a simple UI over the top of the aggregate operation. It allows you to select elements from the FHIR data model and add them to the aggregations, groupings, and filters for the query. Upon execution, the response is rendered as a simple table. We've also used this functionality for some real projects. This is an example where we used the aggregate operation to build a Sankey diagram depicting the relative specificity of diagnoses within the different stages of a genomic test ordering process. We used SNOMED CT coded data with a FHIR terminology server to test for subsumption between the diagnosis codes recorded at each different stage of the process, to determine how effective that process is in refining the diagnosis. Next, we'll talk about the search functionality within Pathling. Pathling provides a special search parameter called FHIRPath. This allows you to express any number of conditions using the FHIRPath language and get back the full FHIR resources that match these criteria. This can be used in conjunction with the aggregate operation to drill down from grouped results. Here's an example of a search query. Here we're using our FHIRPath search profile, and we're filtering to only those procedures which have codes that are subsumed by the concept for shoulder arthroscopy. We're further filtering that to only those records with a status of completed, and then we're also saying we only want the status and category elements back in the response, and we only want at most 5 records in our response. Here is an example from our earlier example for aggregate. Here's one of the rows that we got back in our response, the row which described the number of patients which both were prescribed a TNF inhibitor and also contracted a lung infection. One of the things that comes back with this information in the aggregate response is a drill down expression. This is another FHIRPath expression which can be fed into the FHIRPath search parameter to retrieve the individual records that make up that grouping. So if we gave this expression to the FHIRPath search parameter, we would get the 298 patients that make up this grouping. We're currently working on a range of additional features for Pathling. If you have an interest in any of these, please get in contact, as we may be able to partner with you to deliver these for your use case. The first of these is the summarize operation. This is a way of creating a custom extract from FHIR data. You can provide a set of expressions to the summarize operation, and it will reach into the FHIR data model and create calculated fields for each resource within the dataset. This allows you to prepare data for analysis, including the retrieval of results from terminology operations. Delivering data in aggregate only via an API is compelling within a range of scenarios in healthcare, and we are working on applying the best technology available to reduce the risk of re-identification where this is required. We're also working on supporting the creation and update of individual resources and making these updates available for query in real time. This opens up a whole raft of possible usage scenarios and could be paired with FHIR subscriptions functionality to provide the basis for sophisticated alerting back to clinicians. We're also working on integration into the Python and R programming environments, with the goal of being able to issue a request to Pathling and receive the response back within a native R or Pandas data frame for further analysis and processing within these environments. Pathling is open source under a permissive license, and you are free to use it, modify it, and redistribute it, even in a commercial setting. We're also very open to collaborating on new features for Pathling, as this helps us target the product towards what real users actually need. We have talked about FHIR terminology server integration a number of times within this talk, and there are a number of server implementations that you can use for this purpose. The most functionally complete and performant implementation of the FHIR Terminology Services API is OntoServer, also developed by CSIRO. It's also been primarily developed with the use of SNOMED CT in mind. Here's a link if you want to inquire further about getting access. I'd like to acknowledge my colleagues at CSIRO who have participated and supported me in this work. Kate Eberl, Michael Lawley, Kylin Loy, Madonna Kemp, Sankalp Khanna, Alejandro Metke, and Piotr Zul and Donna Shrurin. I'd also like to acknowledge Associate Professor Andrew Mallett and his team at KidGen and the Australian Genomics Health Alliance, who partnered with us on the genomics test ordering process I referred to in this talk. And of course, thanks to SNOMED International for their continued support in working with us to use our products to demonstrate the power and utility of SNOMED CT and drive further implementation. That brings me to the conclusion of my presentation.
Thank you, John. That was very interesting. Can I ask attendees to give us a moment now while we switch over from our pre-recorded content so that John can address any questions that you've submitted during his presentation. Please also note that this session will be available on the event platform for the next 3 months. Thank you. Thank you, John. That was a very good presentation. So I hope everybody who's online enjoyed it. If you'd like to post some questions in the chat for us, for John, that would be great. And while people are doing that, got one here. Okay, John, what benefit is there in transforming the data to FHIR ahead of the data analytics tasks?
Thanks, Kathy. So in most tasks related to data analytics, we need to take data from multiple heterogeneous systems. We need to combine that together and harmonize the semantics of it in some way. So in other words, we have to transform it to some sort of target domain model. I guess the argument we're making is, why not use a standards-based approach to do that? And in FHIR, we have a domain model that already contains many of the elements within the health domain, and it also contains a lot of the infrastructure that we need in creating a domain model. So it's extensible. It has first-class support for clinical terminology, and it's also machine processable, and it's a format that others can understand. So if you create your domain model in this way, you are setting yourself up for reducing the cost of future implementation, because you are creating something that is inherently going to be more reusable. Instead of creating a bespoke domain model to harmonize data ahead of data analytics, consider using FHIR. And the advantage of that is also we can build tools over the top of FHIR, like Pathling, and you can automate some of the tasks related to your data analytics workflow. Okay, thank you. Okay, another question for you. And while I'm asking this one, if anyone has any, just pop them in the chat and I'll pull them out.
Okay, what sort of things does this approach allow you to do with SNOMED CT that will be difficult if you were dealing directly with RF2?
Okay, so this sort of approach that we were stuck with ahead of the advent of a lot of these tools was taking something like SNOMED CT release format, loading it into tables and interrogating it via SQL. What we have now is things like terminology servers, Onto server, that can sort of index RF2 for you and then answer questions about it. The advantage of this is that you don't have to sort of roll your own queries and logic to do that, which requires not only a very deep understanding of SNOMED CT, but it's also very error prone and it's duplication of effort. So use a terminology server rather than using raw RF2. And then Pathling over the top of that allows you to answer questions of data in conjunction with the terminology. So the terminology server allows you to ask questions like, is this, what are the ancestors of this code? Pathling allows you to answer questions like, what are the patients in this data set which have conditions with codes that are of a certain type, or that of codes that have a particular relationship.
Thank you, thank you. Now, we haven't had any other questions come through, so what I just might suggest to the attendees is if you think of something moving forward from now, you could contact John in the platform, recognising that John's presenting from Australia, so he might not be here in the afternoon. You might have to contact him earlier or via the CSIRO. So thank you very much, John.
Thanks.
I hope you enjoy the rest of the conference. I should say, getting tongue-tied here, the expo. Okay, thank you.
Yeah.